Okay, just a quick video to talk about things that are polar or non-polar. If something is polar, it means that they will have dipole forces to some extent. If things are non-polar, then there will be no dipole forces. So it's important to know whether something's polar or non-polar. Okay, so for example, let's look at methane. We can tell if something's polar or non-polar if there's a resultant pull or push, you could say, in a molecule resulting from an imbalance of electronegativities. So when you look at the electronegativities of these atoms, hydrogen I think is 2.2. We can look at it right down here. Hydrogen, 2.2, and carbon is 2.6. So carbon is 2.6. And this is how much they're pulling electrons. And we know there's a pair of bonding electrons right there. So those electrons, because carbon has a bigger number, those electrons are pulling this way. Okay? But so are these ones, so are these ones, and so are these ones. And so the result of all of those electrons is that nobody's, like this one pushes against this one, so they cancel out. And this one pushes against this one, it cancels out. And so there's no resultant push or pull in that molecule, so it'll be non-polar. Whereas you compare it to this molecule, H. Here, I've got a fluorine instead of a hydrogen, and fluorine's electronegativity is 4.0. And so these electrons here will be pulled way more toward the fluorine. Okay, these ones are pulled this way, this way, this way, but this results in imbalance in charge. So this part of the molecule will be partially negative because it has extra electrons. This side will be partially positive. Okay, so this molecule will be polar. Let's look at a couple others. So say you look at water. Water we draw this way, and we draw it bent like that because there's two lone pairs of electrons here. And according to that VSEPR theory, those lone pair and these bonding pair try and stay as far away from each other as possible. And so this molecule is bent. Because it's bent, these electrons get pulled this way, these get pulled this way, but those don't cancel out. There would be a resulting charge on this side of the molecule of negative and this side of the molecule positive. So water is polar. Maybe compare that to beryllium hydride, where beryllium has 2 electrons and hydrogen has 1. And that's a nice arrangement for beryllium hydride. It just wants to have 4 electrons total. But notice there's no bonding or lone pair of electrons here or here. So these electrons here, I don't know what beryllium's number is. It looks like the electrons would be pulled that way or pulled this way. But it's a tug of war, and these ones would cancel out those ones. So that molecule there, I would probably suggest that would be non-polar. So if you look at any molecule, if it looks imbalanced, then it's more than likely polar. For example, if I look at ethanol. So ethanol looks like this. That molecule, because this is imbalanced, this molecule will be polar. Okay, those are a few examples. Hopefully that clears things up a little bit for you.